Now I will be taking second part of question number 10, exercise 3.3, where I need to prove that express the following the question directions are express the following matrix as the sum of a skew symmetric and symmetric matrix. Now first of all I need to suppose it as a matrix A. So I have supposed that let A is equal to the given matrix. Now so what I need to find first, for finding the symmetric matrix, how can I write? Let P is equal to A plus A transpose. What it will be? It will be 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3 plus, then this is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. If I add them, I get it. The resultant matrix is 12 minus 4 4 minus 4 6 minus 2 4 minus 2 6. Now what I need to find, I can see that this is a symmetric matrix. For showing that P to be symmetric, I need to find P dash is equal to, what will be P dash? 12 minus 4 4 minus 4 6 minus 2 4 minus 2 6 will be equal to, again 12 minus 4 4, row becomes column, this row becomes the column, this row becomes the column, and if I compare, this is just the same as the P, so which implies that P is symmetric. Now again I'll find a new matrix Q which will be equal to A minus A transpose, and I can find that 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3 minus, what will be A transpose? A transpose was again this transpose, 6 row becomes column, 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. What do I get again? If I see the corresponding to corresponding, if I subtract 6 minus 6 0 minus 2 minus 2 plus 2 0 2 minus 2 0 minus 2 plus 2 0 3 minus 3 0 minus 1 plus 1 0 2 minus 2 0 minus 1 plus 1 0 and 3 minus 3 0. Oh, I get this as a, I can see all the elements are there. So in this case it's if I find here Q dash, so Q dash will be, again if I see a zero matrix, it's a zero matrix I have obtained here, and whether I write minus of Q, it's a zero matrix, I write with the capital letter O, and this hardly matters whether I write a minus of Q because all elements are 0. So this says that Q is skew symmetric. Now if I write half of P plus half of Q. What it will be? Half of 12 minus 4, 4 minus 4, 6 minus 2, 4 minus 2, 6 plus half of 0, 0, 0, 0, 0, 0, 0, 0, 0, and which will give me 6, since if I multiply with all the elements to the scalar quantity half, so this will give me 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1 and 3 and plus 0 matrix. So which is the same as the matrix A plus 0 matrix, which is A matrix again. So I can see that any matrix A can be written as the sum of a symmetric matrix and a skew symmetric matrix. So if I have to write the half of P will be this. Half of P I can write, and then half of Q. This way I can express that any matrix can be written as the sum of the, or I can say in the last, matrix A was 6 minus 2, 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 is equal to half of P was 12 minus 4, 4 minus 4, 6 minus 2 and 4 minus 2, 6 plus half of 0 matrix. So this is a symmetric matrix plus skew symmetric matrix. So we can do this question as it is. Now there is another very important property here in the NCERT book. Question number 11, very important. Question number 12, very important, in the page number 90. Now what is that question? If A and B are symmetric matrices of same order, then AB minus BA is, or sometimes it is given here as an option question, sometimes it may be asked to prove that what kind, or to find out the order of the matrix. So how will we do this question? This is question number 11. Question number 11, given that what is given? A and B are symmetric matrix. They are symmetric matrices of same order. Then I need to find out the order of AB minus, I need to find out the AB minus BA is the what kind of matrix it is. So what is given to us? Let me start with that. A is symmetric, that means A dash equal to A. B is symmetric, that means B dash equal to B. Now let us find out, and whatever, if you find AB minus BA, it will be a new matrix. Whatever be, let's see, find out the nature of this. For this I need to apply this. Let's see. If it's a transpose comes the same as, so then it is symmetric. If it's a transpose comes as negative of, then its nature will be skew symmetric. So let us find out. And here we'll apply A plus B whole transpose is equal to A transpose plus D transpose. That property will be applying here. So this can be written as AB transpose minus BA transpose. And again to this, again by the property again, it can be written as B transpose to A transpose minus, again using that property, A transpose minus B. And B transpose, it is written here B again, this is A again, minus this is A again, and this is B. So I see here, if I take minus common, it is equal to AB minus BA. So I can say that AB minus BA transpose is equal to negative of the same. Hence I can conclude that AB minus BA is skew symmetric. Okay, now the question number 12 of the same exercise. That question number 12, it is given that A equal to cos alpha minus sin alpha cos alpha, and the condition is given A plus A transpose equal to I. Then I need to find the value of alpha. Again, A plus A transpose will give me cos alpha minus sin alpha cos alpha, plus A transpose will become, now the row becomes column, cos alpha minus sin alpha and cos alpha is equal to, given that it is identity matrix of the same order, so I can write it as like this. Now what that implies, if I add to the corresponding elements, I get cos alpha plus cos alpha to cos alpha, and this minus sin alpha plus sin alpha becomes 0. Sin alpha minus sin alpha becomes 0, and then it becomes 2 cos alpha. And by comparing the corresponding elements, I get that 2 cosine of alpha equal to 1, which gives me cosine of alpha equal to half. This implied that of alpha, or cosine of alpha equal to cosine of pi by 6. So pi by 3, sorry, this cosine of pi by 3, that means alpha equal to pi by 3.